A very warm welcome to all the students of class 11th who have just picked up their class 11th mathematics book, and the very first chapter is sets. So in this video we will talk about set. And as you have started a new journey after class 10th, this is one important class where you plan for your future. And if mathematics is your subject of interest, then you should really understand the concept of sets, because sets are everywhere in mathematics. So roughly I will take 45 minutes to complete all the concepts in the chapter, and I'll also jot down some important examples and questions. Now let me give you an overview what all things we are going to cover. So our course outline of sets or set theory is, first we will define set, and then we will talk about the meaning of the set. We will learn some notations, and then we will also understand some popular sets. And then we have to focus on how to represent sets. So there is method of representation of sets that we will talk about, and then we will check the types of sets. After that it comes the subsets, intervals, then we will talk about the power set, and then very important concept and topic I would say is the Venn diagram. After Venn diagram we will talk about the operations of set, in which Venn diagram will be used, and then the properties, and then we will study the application of set theory, and we'll do some practical problems. And after this, doing all these things, I hope you will have a very good understanding about sets. And I just want to mention here is that Georg Cantor is one important name if you want to study set theory, because he's the man behind the development of set theory, and that was really very late. So he was born in 1845 and died in 1918. And today all the subtopics of mathematics, or even the main topics of mathematics, whatever it is, everything is connected to set. So set is kind of a foundational structure to most of the mathematical topics, and it is more important now in the modern days, where we have computer science, logic, probability, linguistics. Set made all these subjects easy to understand, yet it was developed so late, because set theory was developed during the year 1874 to 1884, the span of 10 years. Imagine Newton and Leibniz, two mathematicians. They developed calculus. Together they developed calculus. So they actually worked separately, but they came with the same kind of subject, which is today called calculus. And even today's notations in the calculus, what you will study in following month. So these notations, still we use Leibniz notations. Okay, so they developed calculus in the year around 1650. All right, and more than 200 years passed, then this theory was developed, which is called set theory, which is so important in understanding functions and calculus. So set theory made things so easy for us. All right, let us start now with the definition and the meaning of a set. A set is just a collection, a group, a team. So these words can be replaced by set, provided there are some rules that we will discuss. So the formal definition of a set is that a set is a well-defined collection of objects. So set is a group. In a group we have members. In a team we have members, right? Team players. So all these team players are called objects or members. And these members can be anything, almost anything which you can count, okay, which you can name, all right, which you can define uniquely that is something. Now here the term well-defined is really important. Well-defined means you have to be sure about something is a member of that set or not. It cannot be a member as well, that is no problem with that, but you have to be very sure, yes or no. A is a member of a set, A is not a member of a set. If you can answer this correctly, and if your answer is the answer of everybody, then you can say that that collection or that group is a set. So, for example, I just take one example, that if you say set of good batsmen of India. Now, the members, what you include, you can include all the names of Indian cricket players or batsmen, and the names, what you give in this collection. If your friend gives other names, or if your friend says, no, this particular player is, what you have named is not that good. So there, if two people are talking and if there is a confusion that should we keep one person in that good player list or not, then we are not talking about set. There is we don't discuss all these things in set. Set means yes or no. Something is a member of set, yes. Something is not a member of set, that's it. And that is for everyone. It is universal. So we are talking about facts. Now let's take one example which will help you understand what is set. If we say a collection of all the vowels in English alphabet, what all vowels are there? A, E, I, O, U. These are the 5 vowels in English alphabet. And there is no confusion, there is no discussion about it. Everyone knows that these are the 5 vowels. So then it is a set. It is well defined. All right? Now, these elements, these are also called the elements of the set, or the members of the set, or these are called the objects. All right? These objects, when are covered by either a parenthesis like this, or it can be covered by brackets. This way we represent a set. So then we can say this is a set. So to actually write down a set, we have to use these parentheses or brackets. Let's understand the notations used in set. So all you have to understand is that a set can be named. We can give a name to a set, okay? And these names are weird names. I don't like it too much, but this is what we use. We can write all these capital letters like A, B, C. So these are the names of the set up to Z or Z. And to represent the members of the set, we usually use the small letters A, B, C, okay? So this is not fixed, but this is for sure we use the capital letters. The members are not fixed because sometimes you have to write the, your members can be all the students in your class. So you will write the names of your like friends, your classmates, or the roll numbers of your classmates. So every time you don't need to really use A, B, C, D. You can replace it by the actual given identity. Suppose like UID number, Aadhaar numbers. Okay, so these are the Aadhaar number is a unique ID. Why? It has a unique number attached to it. So like that, every student has a unique name. There can be students with a similar name. In that case, also you include the surname, or you write one name A, other name plus B, something like that. You give a unique identity. But for to just name the whole group, we can use these capital letters. And how do we say that? Set A or set B. Now, one more important thing about set is that there is one symbol like this. We call it epsilon. All right. So epsilon is something. So if we say this is the object or member of the set, and here it is set, and we can fill the the blank here by epsilon, which means this object is a member of this set, or we can say this object is in set, this object belongs to the set. And if this object is not a member of the set, it doesn't belong to that set, then the notation becomes something like this. So we write epsilon, but we cross it. So this sign here is, we call it belongs to, or is in, is a member of, and this sign is doesn't belong to, is not in. All right. So why do we use all these symbols, all these epsilon, which is like it's a Greek letter? Why do we use all these in mathematics? Why? Because it makes the work easy. So you don't have to write this object belongs to set A or set B, this object is a member of a certain set. In mathematics you don't have to write that long sentences. In mathematics you need notations so that you can write it quick, okay? And that is the beauty of mathematics. The mathematics can actually read the whole one page of writing can be synchronized or can be compressed in a single simple formula, in a small formula, compact formula, right? So that's why we use all these notations. Now let me give you some important and popular sets, and these are the standard sets which you're going to use throughout your 11th and 12th class. I'm sure that you are familiar with some of these sets. So as we already discussed, that set is nothing but a collection of objects. It can be a collection of numbers. So here we are talking about all these sets which are related to numbers. So capital letter N is a set of all natural numbers, so all counting numbers, 1, 2, 3, 4, 5, 6. Capital letter Z, we symbolize it with capital letter Z, which is a set of all integers. Q denotes the set of all rational numbers. R denotes the set of all real numbers. Z plus, the set of all positive numbers. We also call it Q sub plus. So that position is sub plus. That is the set of all positive rational numbers, and R sub plus is the set of all positive real numbers. And we are going to use these terms in our book, throughout the book, not just for the set theory chapter 1, but for other chapters also. The third topic is representation of sets. So we represent set in using two methods. So one is called the roster method, and the second one is property method. In roster method, we simply write all the members of the set. So we use the parenthesis and we just write all the members. So as we have written A, E, I, O, U. So this is the roster method. We jot down all the members of the set. Another example for roster method would be all the letters in the word school. So this is your word school, and in roster method, if we have to write that in a set, so we will actually write all the members of all the letters of the word school. So what all words are there? S, C, H, O, and here you can see O is 2 times written. So in school we have O 2 times, but to write as the member of a set in a set, we only write any member once. We don't have to write it 2 times. So number of the same kind of element is of no use. It is vague in set. So we strictly prohibit repetition of members. Let's take one more example. We can say that the set of all natural numbers between 3 and 10, and to write in the roster form, we just have to write all the members. So the natural numbers we have to count in between 3 and 10. So we will not include 3 and 10. We will write all the natural numbers in between 3 and 10. So that is 4, 5, 6, 7, 8, and 9. That's it. Now the same number, like same members in a set, can be written in a different way. And that is the property method. In property method, we write the properties. We write a kind of a, not a formula, I would say, but some common characteristics of all the members of the set. So, and to write that, we usually use this kind of symbol. So we can say that let's A is equal to a set, and then we give the notation of the set. Here we are not going to write all the members of the set. We will use a different property or a characteristic of the set. So we write it like X is such that X is or is in N, and as you know, N represents natural number. So X is such that X is a member of N. X is a natural number. Okay, but it is not complete. We still have to write something else. Some other properties are there. That is, this X is less than 10 and greater than 3. That's it. And this is the property method of writing a set. Now this symbol here, it is really important. If you don't know, it doesn't matter. It is important. These symbol less than or greater than. These symbols, if this symbol is used just like that, it means we are not including 10 here. This side, it means we are not including 3 here. We will come to know this when we will study the intervals in the same chapter. So just be relaxed for now. It is not gonna trouble you. So for now, in the property method, what do? We actually write the properties of all the elements of a set. So we write the properties in a very compact way, using notations and using formulas, so that all these properties fit in the definition of the given set. All right. So this is the end of part 1, because I am not in a favor of doing a very long video for 1 hour, which becomes, at times it becomes boring. For me, it is a bit boring. So what I'm gonna do is, I'm not gonna extend the time. So I'm very hopeful that 45 to 50 minutes is the maximum time I will cover the chapter. And you should exclude the introductory part where I talked about a few other things. But this is part 1, and I will come with 2 more parts, part 2 and part 3, of 15 to 18 minutes, and that's it. Maximum 20 minutes, and that's it. And in 3 videos, you will learn all the important concepts in set theory, and you will be able to solve the problems in set. And thank you for watching so far, and see you in the next video. Bye.